What is P0? Integration of a to b f of x dx can be written as integration of a to b f of t dt, or integration of a to b f of theta d theta. Instead of x, you can put upper limit plus lower limit minus x. Integration of a to b f of x dx can be written as minus integration of b to a f of x dx. Simply P1 means when you interchange the limit, sign changes. Welcome to the session, dear students. So today I'll go ahead with definite integral properties, which are most important to learn application of integrals. So now, definite integrals, already we have done problems. Definite integral means what? When they give limits, integration a to b f of x dx. So we can use properties. In your NCERT textbook, we have property P0 to P7. So P0, integration of a to b f of x dx is integration of a to b f of t dt. Meaning is simple. You can replace the variable. So instead of x dx, you can put what? T dt. What is P0? Integration of a to b f of x dx can be written as integration of a to b f of t dt, or integration of a to b f of theta d theta. So here x dx, instead of x dx, you can replace it by t dt. Simple and easy property. Means if I have integration of 0 to pi by 2 sin x dx, you can write it as integration of 0 to pi by 2 sin theta d theta. Then integration of a to b, P1, integration of a to b f of x dx can be written as integration of b minus integration of b to a f of x dx. Simple. When you interchange limits, here it is from a to b. If you make it b to a, sign changes. If you make it b to a, sign changes. So here, if both upper limit, lower limit both are same, it is 0. A to a means, integrate means combine from a to a. A to a, what is the distance? It is 0. So if it is a to a, it is 0. Or P1 is when you interchange the limits, the sign changes. For example, if I have integration of 2 to 3 x square dx, I can also write it as integration of, instead of 2 to 3, you can write 3 to 2. When you write 3 to 2, it changes to negative x square dx. Means when you interchange upper limit and lower limit, the sign of the integral changes. Integration a to b f of x dx can be written as minus integration of b to a f of x dx. Means when you interchange the interval a to b to a, the sign changes. P0, P1, P2. Integration a to b f of x dx can be written as integration of a to c f of x dx plus c to b f of x dx. Means a to b I can reach through c. First I'll go from a to c, then I'll go from c to b. Means integration of a to b f of x dx, I can write it as, first I'll write integration a to c f of x dx, then plus integration of c to b f of x dx, where c is a value lying between a and b. C should lie between what? A and b. So integration of a to b f of x dx can be written as integration of a to c f of x dx plus integration of c to b f of x dx. So P0, P1, P2, three properties are easy and important. What is P0? Just replace x dx with t dt. What is the P1? When you interchange the limits a to b to a, sign changes. What is P2? A to b can be reached through c. First you can go from a to c, then you can go from c to b, where c should lie between a and b. And then we have integration a to b, P3. Integration a to b f of x dx can be written as integration a to b f of a plus b minus x. F of a plus b minus x dx. A plus b means what? Upper limit plus lower limit plus upper limit minus x. You can replace x with a plus b minus x. So you can replace x with what? Instead of x, you can put a plus b minus x. So this is f of x dx. This will become a plus b minus x dx. So P0, P1, P2, P3 are most important. Then we have other four. So now just four properties I guided you. Let me summarize four properties. What is P0, dear students? P0 is integral of a to b f of x dx is same as It is same as what? Integral of a to b f of t dt. Meaning is simple. X dx can be replaced by t dt. And P1, what is P1? Integration of a to b f of x dx. You can write it as b to a. Instead of a to b, you can write b to a f of x dx. So when you interchange the limit, the sign changes. Integral of a to b f of x dx can be written as minus integral of b to a f of x dx. And P2, what is P2? Integral of a to b f of x dx can be written as a to b can be reached through what? C. So integral of a to c f of x dx plus integral of c to b f of x dx, where c is a value lying between a and b. C is a value lying between a and b. And P3, what is P3? Integral of a to b f of x dx can be written as integral of a to b f of a plus b minus x dx. Meaning is simple. You can replace x with a plus b minus x. Instead of x, you can put upper limit plus lower limit minus x. So now in today's class, P0 to P3 will derive. So other than that, we have P4, P5, P6, P7. P4 is what? 0 to a f of x dx can be written as 0 to a f of a minus x dx. Same like last case, there a plus b, here 0 plus a is what? A. And P3, if you can derive P4 also. Then P5, P6, P7 are most important. So any one you can expect for your board exams. 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. Then 0 to 2a f of x dx can also be written as 2 times 0 to a f of x dx if suppose 2a minus x is same as x. And P7, if a minus a to a f of x dx becomes 2 times 0 to a f of x dx if function is even. If it is odd, it will become 0. So P4, P5, P6, P7 are also important. So from P4, we'll go ahead in my next session. So in today's session, I'll be guiding you P0, P1, P2, P3. We'll derive P0, P1, P2, P3. So 4 properties. You should become thorough with 4 properties with number. Then P4, P5, P6, P7 will go ahead in my next session. So let us derive each. Now first property, all of you know. What is first property? P0. What is P0? Integration a to b f of x dx is equal to integration of a to b f of t dt. So instead of f of x dx, you can put what? F of t dt. So replace x with what? T. See here, I'm just removing x and I'm making it what? T. T dt. X dx becomes what? T dt. If you take the thing here also, instead of x dx, it will become what? T dt. So ಇಲ್ಲಿ x ಇದೆ, ಇಲ್ಲಿ dx ಇದೆ, ಇಲ್ಲಿ t ಇದ್ದಾಗ ಏನು ಬರಬೇಕು? dt. So we removed x and we made it what? T. So I wrote it here. Integration of a to b f of x dx can be written as integration of a to b f of t dt. So now how to prove this? So proof is simple. So they'll ask, prove that integral of a to b f of x dx is equal to integral of a to b f of t dt. Simple and easy. Just do substitution. Let t is equal to x, I'll assume. Differentiate both sides with respect to x only will do. Then LHS becomes d by dx of t is equal to RHS d by dx of x. So dt by dx is equal to what? 1. Or dt is equal to what? Dx. So now you can do the replacement. I'm assuming t is equal to x. In the place of x, put t. So dx becomes dt. So you can do the replacement. And whenever you do substitution, you should also change the limits. So what are the limits? So when x is equal to lower limit a, t, what is t? T is x. T is also a. When x is a, t is a. When x is equal to upper limit b, t is x, t is also b. So now take LHS. What is LHS? Integration a to b f of x dx can be written as integration of when x is a, t is also a. When x is b, t is also b. F of in spite of x, we assumed x is equal to what? T. And dx became what? Dt. This is the RHS, hence the proof. So what is the conclusion? Conclusion is simple. When you replace the variable, you have to replace the with respect to, that is derivative, x dx, or you can write t dt, or you can write theta d theta. So one simple example, if you have integration of 0 to pi by 2 sin t dt, you can also write it as integral of 0 to pi by 2 sin theta d theta. Both are same. Means in spite of t dt, you can write theta d theta or x dx. That is the meaning. So this is a proof. So what we have done, we have taken LHS. In LHS, we assumed x as t and dx becomes dt. And when x is a, t is a. When x is b, t is also b. So these are the substitutions we have done. Next, say if you have integration of 2 to 3 f of x, 2 to 3 x square dx. Same problem you can write it as integration of 2 to 3 t square dt. Or you can also write this as integration of same limits 2 to 3 theta d theta. All are same. So here if you do that, so what is integration of x square? X cube by 3. From where to where? 2 to 3. So in the place of x, 3 cube divided by 3 minus 2 cube divided by 3. So here t cube divided by 3. From where to where? 2 to 3. In the place of t, we have to apply. It will become 3 cube by 3 minus 2 cube by 3. Or here, theta square divided by theta, that is 2 to 3. This will also become 3 cube. In the place of theta, you should apply the limit. 3 cube by 3 minus 2 cube by 3. So you can see everything gives you same answer. So what is a P0? What is P0, my dear students? P0 is, property 0 is integration of a to b f of x dx can also be written as integration of a to b f of t dt. What is the meaning? Meaning is simple. You can replace the variable and corresponding with respect to. If I write x with respect to dx, then I can also write t with respect to dt, or the same thing without changing limits, I can write theta with respect to d theta. Both are same. So memorize it. Wherever it is necessary, we'll use P0. P1, integration a to b f of x dx can be written as integration b to a minus b to a f of x dx. Meaning is when you interchange the limits, the integral sign changes. So now you will take LHS and will arrive at a result. I'll take LHS. What is LHS? Now I'll try prove that they'll ask. Prove that integration a to b f of x dx is equal to minus integration b to a f of x dx. So now in this, how to prove? LHS will take. What is LHS? Integration of a to b f of x dx. Before we start this LHS, we have to assume, let integration of f of x, let us assume it gives you g of x plus c. So indefinite integral value. Integration of a to b, I will take it as g of x. You know, integration of sin x is minus cos x. Integration of 1 by x is log x. So integration of one function is giving you other function. So I am assuming, let integration of f of x is g of x. So now integration of a to b f of x means what? First you integrate. When you integrate, you will get what? G of x. This is our assumption. Then from where to where? A to b. So apply upper limit minus lower limit. What is upper limit? G of b minus g of a. Upper limit minus lower limit means what? In the place of x put upper limit, minus in the place of x put lower limit. So now you got LHS. LHS is what? G of b minus g of a. Now we'll take RHS. Take RHS, right hand side. So what is there in RHS? The minus integration of b to a. So when you interchange the limits, b to a f of x dx. Now integrate this. What is integration of f of x? We assumed g of x. From where to where? Outside we have minus. So b to a. This minus as it is. So minus as it is. So upper limit minus lower limit. G of b minus g of a. Now take it inside. When you take it inside, it will become minus g of a plus g of b. I'll rearrange. If I rearrange, it will become g of b minus g of a. I call it as equation 2. So now g of b minus g of a. Here also when you take minus inside, minus of minus becomes plus g of a, and this will become negative g of b. So I'll rewrite. So this is also g of b minus g of a. So from LHS, from 1 and 2, what is the conclusion? So now directly I can write from 1 and 2, from equation 1 and 2, I got LHS is equal to RHS. LHS is equal to RHS means what? I got integration of a to b f of x dx value. I got same as integration b to a but negative, minus b to a f of x dx. Both gave me same values. So let us take one example. So I'll take example. So integration of 0 to pi by 2 cos x dx, suppose. Now we'll find integration of 0 to pi by 2 cos x dx. All of you know what is integration of 0 to pi by 2 cos x dx. Integration of cos x is positive sin x. From where to where? 0 to pi by 2. 0 to what? Pi by 2. Now you know upper limit minus lower limit. Sin pi by 2 minus sin 0. What is sin pi by 2? Sin 90. What is sin 90? 1. Sin 0, 0. So you got 1. Integration 0 to pi by 2 cos dx gave you what? 1. Now consider reverse. I'll take pi by 2 to 0 but negative, minus cos x dx. Cos x dx. Same problem I'm taking. I'm taking negative and I'm interchanging. I should get same. We'll see. Minus outside. All of you know integration of cos x is sin x. From where to where? Pi by 2 to 0. Now upper limit is what? 0. So sin 0 minus sin 90. Sin pi by 2. All of you know sin 0 is 0. Sin 90 is 1. Minus of minus 1 becomes what? 1. So you got again 1. What is the conclusion? Therefore, integration 0 to pi by 2 cos x dx value, I got same integration cos x dx but negative pi by 2 to 0. Means when I interchange 0 to pi by 2, it become negative. That's it. So this is P1 we proved. Now we'll go to P2. Integration a to b f of x dx can be written as integration of a to c f of x dx plus integration c to b f of x dx. Means a to b f of x dx I can reach through c. So a to b I can go through c. First I'll go to c, then I'll go to b. Where c should lie between what? Strictly c should lie between a and b. This is a condition. So now let us prove this. How to prove this? We'll take LHS will arrive at a result. Then we'll take RHS will arrive at a result. Same technique we can use. So let me solve. Now let us assume let c is a value lying between a and b. And integration of a to b, I'll take integration of f of x dx. I'm assuming integration of f of x, I'm taking it as g of x plus c. Means integration of one function gives you, it is indefinite, so I should put plus c. Now coming to LHS, we'll find LHS. So I'll do only LHS here. What is LHS? Integration of a to b f of x dx. This is LHS. All of you know what is the integration of f of x. What is integration of f of x? Integration of f of x is g of x. From where to where? From a to b. So apply upper limit minus lower limit. So it will become g of b minus g of a. So call it as equation 1. Now we got LHS. A to b f of x dx. I got g of b minus g of a. I should take RHS and I should arrive at same. So we'll go to RHS. What is RHS? We have taken RHS is integration of a to c f of x dx plus integration of c to b f of x dx. Now we assumed f of integration of f of x is g of x. From where to where? A to c plus integration of f of x is g of x. From where to where? C to b. Now as usual, apply upper limit minus lower limit. Then it will become g of c minus g of a plus apply upper limit minus lower limit. It will become g of b minus g of c. Now you can observe positive g of c, negative g of c cancels. And we have minus g of a plus g of b. I'll write it as g of b minus g of a. So call it as 2. See, we got this and LHS g of b minus g of a. RHS g of b minus g of a. So what is the conclusion? From 1 and 2, I can conclude LHS value is same as RHS value And therefore, what is the conclusion? Therefore, integral of a to b f of x dx value is same as integral of a to c f of x dx plus integral of c to b f of x dx, where c should lie between what? A and b. We have many problems or many examples where we can solve. You know mod x. Mod x value is positive and x is greater than 0, and mod x is negative and x is less than 0. So I'll take a problem like this. Integral of minus 1 to 1 mod x dx. So I can write it as integral of minus 1 to 0 mod x dx, and from 0 to what? 1 mod x dx. You know, minus 1 to 0 means negative. When it is negative, mod x is minus x dx. When it is positive, mod x is positive x dx. Mod x value becomes minus x. You know, mod x is a piecewise function. Mod x will have two values. So mod x is minus x when x is less than 0, and mod x is plus x when x is greater than 0. So therefore, mod x I'll write minus x. Here mod x I'll write plus x, because this is 0 to 1. 0 to 1 means positive. This is minus 1 to 0. Minus 1 to 0 means negative. Now you can integrate. What is integration of x? X square by 2. From where to minus outside? Minus 1 to 0. And plus integration of this is x square by 2. From where to where? 0 to 1. Now again apply upper limit minus lower limit for this. Apply upper limit for no minus lower limit for this, you will get. So where problem will have more than one value for the function, between the limits, we can use this property. Integration of a to b f of x dx can be written as integration of a to b f of x dx can be written as integration of a to c f of x dx plus integration of c to b f of x dx, where c is a value between a and b. Then we have P3, most important. Integration of a to b f of x dx can be written as integration of same a to b. In spite of x, we'll write a plus b minus x. In spite of x, write what? Lower limit plus upper limit minus x. A plus b minus x. Now, we'll take RHS and we'll arrive at LHS. We'll take RHS and we'll arrive at LHS. So now, because RHS contains the internal term greater. See here, a plus b minus x. So integral of a to b f of x dx can be written as integral of a to b f of a plus b minus x dx. So replace x with a plus b minus x. That is the thing. Take RHS and arrive at LHS. They'll ask you to prove this. So we'll prove integral of a to b f of x dx is equal to integral of same a to b f of a plus b minus x dx. They'll ask you to prove this. See, from here the proof starts. For 6 marks in your board exam in part E section, they'll compile 6 plus 4 marks. So these kind of questions. We'll take RHS. We'll take what? RHS. What is RHS? Integral of a to b f of a plus b minus x dx. We'll do the substitution. So put t is equal to the internal term. What is the internal term? Put t in the place of a plus b minus x. I am assuming t. Put t is equal to a plus b minus x. Means in the place of a plus b minus x, take it as t. Now differentiate both sides. D by dx of t is equal to, all of you know, d by dx of a is 0. D by dx of b is also 0. D by d minus d by dx of x is 1. Derivative of a constant 0. Derivative of b is constant 0. Derivative of minus x is minus 1. And we'll get dt. What is dt? Dt becomes minus dt dx. Or what is dx? Dx is minus dt. So whenever you do substitution, we want dx value. So now a plus b minus x, in the place of a plus b minus x, you can put t. You can, in the place of dx, you can put minus dt. So whenever you do substitution, you should change the limits also. So now I should take the limits. So we took the substitution. What is the substitution? T is equal to a plus b minus x. So now what is the, when x is equal to a? When x is equal to a, what is t? T is a plus b minus a. A cancels, t is b. When x is a, t is b. When x is equal to b, in the place of x, if I put b, t is equal to a plus b minus b. Plus b minus b cancels, t is what? A. When x is b, t is b. So limits, x is a, t b, x b, t a. Limits also changes. So now I'll go to the problem. So what is the substitutions? So this is the substitution. From this we got dx value is minus dt. All these things will take in LHS. RHS. What was RHS we have taken? RHS is integration of a to b f of a plus b minus x dx. So you can see when x is a, t is b. So when x is a, t is b. When x is b, t is a. In the place of b, put a. F of a plus b minus x. A plus b minus x, we took it as what? T. In the place of a plus b minus x, t. And dx is what? Minus dt. I can take minus out. Minus, I'll take it out. I'll have b to a, f of t dt. Observe this carefully. I can use property P1. What is P1? When you interchange limit, sign changes. Now, negative b to a, instead of negative b to a, I can write positive a to b. F of t dt. Can I write this? Since by P1. What is P1? Integration of a to b f of x dx can be written as minus integration of b to a f of x dx. Simply P1 means when you interchange the limit, sign changes. So here it is b to a negative. So if I make it positive, it will become a to b. So interchange the limit. So negative becomes positive by property P1. By property what? P1. Then P0. What is P0? Integration of a to b f of x dx can be written as integration of a to b f of t dt. Or integration of a to b f of t dt can be written as integration of a to b f of x dx. So same, I'll write integration a to b. Instead of t dt, I can write x dx. So this is what? LHS. I took RHS, arrived at what? LHS. Integration a to b f of a plus b minus x dx becomes integration a to b f of x dx. So I took RHS, I arrived at what? LHS. Hence the proof. Now, by this, we have done the property P3. We have done the property what? P3. So, P0, integration a to b f of x dx can be written as integration a to b f of t dt. You can replace x dx with t dt. P1, integration a to b f of x dx can be written as integration minus integration b to a f of x dx. Means, if you interchange the limits, sign changes. P2, integration a to b f of x dx can be written as integration a to c f of x dx plus integration of c to b f of x dx. Means a to b can be reached through c, where c is a value between a and b. And the P3, what we have done, that is integration of a to b f of x dx can be written as integration of a to b f of a plus b minus x dx. Meaning is simple, x can be replaced by a plus b minus x. Limits will be same. So P0, P1, P2, P3, 4 properties, P0 to P3. Memorize and become thorough. And we have proved it. And understand this and learn the properties. Later, we will not derive the property. We will apply these properties. So you can see in this proof, P3, I have applied P1. So I have applied P1 and also I have applied here P0. Here I applied what? P0. What is P0? All of you know P0 means what? T dt can be replaced by x dx, or x dx can be replaced by t dt. And we took RHS and we arrived at what? LHS. So P0, P1, P2, P3, 4 properties become thorough. In my next session, I'll add P4, P5, P6, P7, another 4 properties which are most important, and then we'll go ahead. So if you are thorough with P3, P4 is similar. P4 is also similar. Thanks for attending the session. I'll see you in my next session. Thank you.